Hello there, physics students. The purpose of this video is to review and practice with some of the more complex problems dealing with balanced forces. So first we'll go over a couple tips for solving these more complex problems, and then we'll jump into some examples. So when you stumble upon a complex problem, the best thing to do is to start with a free body diagram, because that's just going to give you a foundation for solving. Then, if you have any diagonal components, so any diagonal forces that are drawn on your free body diagram, you want to find the x and y components. And that's going to help you when you're trying to solve for what you're looking for, because you'll know what the horizontal components are and what the vertical components are. Once you solve for those horizontal and vertical components, you can ignore the diagonals when it comes to solving, and then you can solve for the unknown. You want to keep in mind that horizontal and vertical forces should be balanced when an object is at rest and when an object is moving at a constant velocity. So with all of these things in mind, let's jump into our first example. Now I'm going to read you this example 1, and I want you to pause the video after and try to solve the problem. So example 1, Jeff here pushes this 56 kilogram lawnmower at a constant speed with a force of 415 newtons at an angle of 43 degrees to the horizontal. So A is asking you to find the magnitude of normal force by the ground on the lawnmower, and B, find the magnitude of friction on the lawnmower by the ground. So before you pause the video, I want you to keep in mind that we're given the mass, we're given the diagonal force, 415, and we're given the angle from the horizontal. And this word magnitude, don't get too thrown off by it. As a reminder, it just means the amount. So we're looking for a numerical value here for A, the normal force by the ground on the lawnmower, and B, the magnitude of friction on the lawnmower by the ground. So go ahead and pause the video, and don't forget to start with your free body diagram. When you've tried drawing your free body diagram, solving for A and B, then you can start the video again and see if you got it right. Alright, so let's check out how you did. I'm going to start with the free body diagram, so I'll draw it over here to the right. So I'm going to start with my dot, and then I have my weight, which is labeled weight, earth, on the lawnmower. I also have my normal force by the ground on the lawnmower, and that's going to be that. So normal on lawnmower. Then I have this diagonal force that it's going this way, so I'm actually going to draw it that direction. Maybe I'll make it a little shorter. No, we'll just leave it. Okay, so that's going to be normal, Jeff on lawnmower. And last but not least, I have friction. So I've drawn my free body diagram, and now I'm going to identify and label my components, horizontal and vertical, or x and y, for my diagonal. So I'm actually going to color code this. So my x component, I'm going to call it nx, is there, and my vertical component is there. I'm going to call it ny. So what that does is it allows me to see that this diagonal force here is actually a combination of horizontal and vertical. So I have to keep that in mind because later when I solve for the unknowns, I am going to keep in mind that the left force should balance this right force, and this up force should balance this plus this. So we'll get to solving later, but I'm going to actually solve for what I can with this diagonal. So if you recall, we were told that this push force is 415, and that this is a 43-degree angle. Well, that tells me enough information to solve using trigonometry. So I'm going to solve for ny first, and we're going to use sine, because this is opposite, over the 415. So that comes out to 283.03 newtons. And my x component, or horizontal, we're going to use cosine, and that comes out to 303.51. So now that I've solved for the components, I can actually sort of pretend like this doesn't really exist while I'm solving, because I have my horizontal and vertical component. So moving on, what else do I know? What else can I find as far as magnitudes or amounts of forces? Well, if you remember correctly, we were also told the mass, and if you recall, weight is equal to mass times gravity. So that means it's 56 times 10, so our weight is 560 newtons. And we're getting closer, so let's recall what we're actually looking for. We are looking for the normal force by the ground on the lawnmower, which is this guy. And we're also looking for the friction, which is this guy. So let's solve for the normal force by the ground on the lawnmower. Well, if I can sort of create an equation for my up vectors equaling my down vectors, or all my vertical vectors balancing each other out, it looks like it's going to be normal force ground on lawnmower equals my ny plus weight. And I got that by saying, okay, well, I know that this has to equal this plus this, or they have to balance each other out. So normal force ground on lawnmower equals my ny, we solved for right here, is 283.03 plus my weight, which is right here, it's 560. And we end up with a normal force of 800, oops, let me erase that. We end up with a normal force of 843.03 newtons. So that's part A. So we solved that. And now to part B. Whoops. So part B is a little simpler here, because we know that nx here and friction have to equal each other, because this is the only left force and this is the only right force. And if this lawnmower is moving at a constant speed, we know that they have to be balanced. So nx has to equal friction, and we know that nx is 303.51 because we solved for it right here. So that is our friction. So that we check off part B. So go ahead and fix anything that you had gotten wrong and write any questions you have down, and we'll move on to the next question.